so I guess it's time to get started here. My name's Taylor Otwell. I wrote the Laravel framework a few years ago, and this talk is about kind of how Laravel works under the hood. So it's a little bit more of an advanced talk than I've done in the past, I think, but I've tried to break it down to into little pieces so it's easy to keep up. A little bit about me. I am a lifelong Arkansan. I'm from Arkansas. I graduated from Arkansas Tech University in 2008. I started programming, my professional programming career doing enterprise.NET and legacy COBOL. So we had like an ASP.NET MVC front end that piped to a COBOL backend on a mainframe. So it was a weird mix of new school and very old school. And then in 2011, I wrote Laravel because I had some side project ideas that I wanted to flesh out, just like some different startup ideas. And it's a little tricky to host .NET on your own. It's more expensive. It's more complicated than hosting PHP. So PHP was kind of a natural choice in terms of language to use that was easy to get going. And then I joined Userscape in 2011. So Ian Lansman, my boss, he saw Laravel. This is back when Laravel was not very popular. And he thought it looked cool, and he wanted to bring me on board to build some new help desk products. So I've done that for the past few years. And at the end of this year, I will go full-time on Laravel and working on Laravel and Laravel Forge, which is a server provisioning tool. I also wrote a book, which you can have for free. It's leanpub.com/Laravel, and the coupon code is phpworld123. I put 100 uses on the coupon, so I think that should be enough. But if it's not, just let me know. All right, so about Laravel's philosophy, I'll kind of like lay some groundwork first before getting into the code and stuff. We have this cheesy motto that's developer happiness from download to deploy. And that means a lot of different things to different people. So some goals are we aim for simplicity, which who doesn't? I mean, everyone's trying to write simple code and maintainable code. We have minimal configuration. So like if you download Laravel and you install it, you don't really have to do a lot of configuring out of the box to get things to work. Things pretty much work how you would expect out of the box. So things like authentication and logging people in and sessions and even like email and queues is pretty easy to configure with maybe just one or two options. Laravel has a real terse syntax, so there's a lot of methods. There's almost any methods that are two words. They're almost all one word, like redirect to or auth check or queue push. It's very simple syntax, and that makes it very memorable and easy to learn. We also have a lot of kind of powerful infrastructure that was kind of new to PHP frameworks. Like queue is a good example. You can push a closure out onto a queue. You can use various queue backends. We have a powerful Ioc container, which I'll talk about in a little bit. And we embrace the PHP community. So Laravel currently uses 21 community packages that are not written by us. That includes 9 Symfony packages and then a host of other packages. So that's things like Symfony's routing component, their console component. We use Carbon, Monologue, SwiftMailer, all like top of the line PHP components from the community. And that really takes a big load off of me and the rest of the Laravel community, because we can kind of focus on our stuff, which we have an ORM, our authentication system, our queue system, and let other people worry about those components. So when a lot of people will mention like they like to glue a lot of components together, and that's really like what Laravel is. It glues a lot of the best PHP components together into a usable framework, and then kind of sprinkles our own flavor on top and some of our own components. Okay, so just to give a few examples of what Laravel looks like if you've never seen it before. It does do dependency injection by default on all controllers and queue handlers and event handlers and most other things. So simple, when I say simple, I don't necessarily mean stupid. I don't mean the absolute most basic way to code. I just mean simple and intuitive ways to code. So if you type hint something on a controller, it's going to be automatically injected by your dependency injection container. You don't really have to configure anything. So you can just ask for a class and it will be injected in. You can also do this on methods. So like right here, I can type hint this create photo request, which might have some validation rules, and that will be injected in automatically as well. So some pretty powerful features that let you build more testable and flexible code there. Our ORM is an active record implementation, so this would be in contrast to something like Doctrine, which is a data mapper. But just an example of the syntax so you can get an idea for what it looks like if you haven't seen it. You can just say, I want to get all photos with comments, so that would be like an eager load. So pull in all the comments for these photos in 2 queries instead of n+1 queries. And where the user ID is whatever, and then get all those photos. And then you can real easily convert those to JSON. So Laravel is really nice for working if you're doing like Angular work or you're doing a JSON API. Laravel is really nice to work with in that scenario. For routing, it can also look a lot like Silex or another kind of simple router. So you can just pass a closure into a route declaration, and that will be run when that URI is called. And then I could just return out an eloquent result, which will be automatically converted to JSON because it implements the JSON serializable PHP interface. All right, so we also have a few other things that are not usually considered core framework features. So this is an optional package called Laravel Cashier, and it provides Stripe subscription management for your users. So you can subscribe people to plans, you can swap plans, which handles prorating, the prices, you can add coupons, you can do a lot of different things, and then you can check if they're subscribed. And it's all a very fluent, simple interface. So if you're building like a new SaaS startup, subscription billing is really like a pain in the neck. And even though the Stripe API, I know it like sounds developer friendly, but it has a lot of weird quirks in terms of how prorating works, in terms of if you cancel a subscription. Most likely in the human world, you want to continue that subscription until the end of their billing period so that they get the rest of their time. Stripe doesn't have a big concept of that, or it's not very intuitive. So Laravel Cashier can really help alleviate a lot of those that weirdness in Stripe's system. All right, and this is not Laravel specific really. You can use this with any of your other projects. There's also a lot of other things in the Laravel ecosystem, so to speak. So a lot of surrounding tools and products. There's Laravel Homestead, which is a Vagrant machine, and you can use that with things that aren't Laravel. So you could use that with WordPress or Drupal or Symfony or Zend or whatever. It's just a nice PHP virtual machine. If you haven't used Vagrant, definitely check that out. It will make your development life a lot easier because you don't have to muck around with your main operating system. Laravel Forge, which is I think of as kind of a poor man's Heroku. It is a $10 a month service that can provision servers on DigitalOcean, Linode, and then any custom VPS, so like Amazon or Rackspace or anything like that. And for $10 a month, you can do unlimited servers. It's a little different than Heroku in that you still own the server yourself. It's not like a fully managed infrastructure. So that's why the price is lower. And Heroku's price, you're paying a premium for them to manage it and stuff. So it kind of depends on what you want, but it can be a helpful tool. Laravel Elixir, which is a simplified gulp. And then we have Laracast, which are video tutorials, and then Laracon and Laracon EU. So if you're not familiar with Laravel, that's kind of a rundown of what it's about. But this talks about how does it work. So we're going to start where Yoda would start, which is the Ioc container. And to start with the Ioc container, we first need to talk about dependency injection. And dependency injection is a big word for something very simple. And basically it is, instead of doing something like this top code example where we're creating a MySQL connection right in the constructor of this class, we just want to pass a MySQL connection in. That's really all dependency injection is. Okay, so why do we want to do that? To use another example, say we want to send emails from a class. We're going to pass a mailer in because it's going to let us easily test this code. So right here I can mock that mailer. I can set some kind of expectation that should be called. So I'm going to say when I run this method on this service, I expect the mailer to be called once, the send method. And then I can pass in my mock implementation into the service. So when you use dependency injection, you get a lot of benefits. One of them is it's easy testability. Another one is easier to swap implementations, and it also makes your code more explicit, so to speak. So if I'm consuming the code, I know that it needs a mailer, and it's obvious that this is doing some kind of mailing stuff. It's not kind of hidden under the API. Does that make sense? But you don't need a dependency injection container to do dependency injection. It's just a convenience tool. It just makes your life easier. You could do it all by hand. So you could pass all your dependencies manually into every constructor. That would work fine. That would be dependency injection. Containers are nice because you don't want to have this all throughout your code. It's just inconvenient. So say you have a new discount broker, needs a new repository, needs an event dispatcher, the logger needs an email driver, which needs an SMTP thing. It's just a hassle. So containers can build these kind of complex object graphs for you and can automate a lot of that throughout your code. Has anyone ever used an IOC container? Okay, fair number of people. Okay, there is another way to use a container, a service container, which is called service location. So in this scenario, you would pass a container into a class in the constructor, as you can see, and then say our vacation booker is going to book a vacation for a certain hotel and dates, and it actually, when we call that, asks the container to give it a mailer. This is probably still testable, but it hides the dependencies of these classes so that they're not very obvious to the consuming code. And your code is kind of like lying at that point in a way. So you probably want to avoid this and keep your dependencies more explicit through dependency injection. All right, now to get Laravel specific, let's talk about Laravel's IOC container and what it can do. All right, the IOC container is in this Illuminate container component, which really has no other dependencies. You can pull that in and start using it with any project or even just in a plain PHP file just to tinker around with it. And let's pretend we have this SMS notifier in our vacation booker, and our vacation booker takes the SMS notifier in its constructor. We're going to new up a container instance, and then we can just call container make vacation booker. And this is the auto-resolving capability of Laravel's IOC container. When I ask for that class, it will use PHP's reflection libraries to read this constructor right here. It will read that it needs an SMS notifier. And it will say, okay, I need to make that, and then pass it in. And it will do that all the way down the chain. You know, if that has a dependency, it will read its constructor. So this is a really powerful and handy feature because if you have a class like a controller or some other domain service that needs dependencies, I can just add it to the constructor. I don't have to go configure anything else. So it's a really handy feature to have. And in the same way, I can take away dependencies and not have to worry about configuring anything. Okay, so that's the reflection-based approach to resolving dependencies. There's also a second way to configure the container, which is registering closures. I can say I'm going to bind something in the container called vacation booker, and when I need a vacation booker, I want you to call this closure, this anonymous function. And whatever that returns is going to be my vacation booker. So in this example, the container will be passed to your closure so that if you need to resolve any other dependencies, I'm just going to return a new vacation booker and then make my SMS notifier out of the container, or whatever else I need to do. So you can do whatever you want in this closure to build this object. Okay, so this is a more manual way to configure the container, so it's not going to use the reflection at this point when you need a vacation booker. You can also do singletons, or some containers call them like shared instances, where say you only want one vacation booker instance throughout your whole application, or you only want one logger or one emailer. You can tell it that you want that to be a singleton, and after it creates that first instance of the vacation booker, it will use that same instance on subsequent requests to the container for that type. Okay? The container can also bind interfaces to implementations. So I can say, I want to bind this interface to X implementation. So remember our SMS notifier. Say we had a notifier interface, and we had an email notifier, and an SMS notifier, and a smoke signal notifier, or whatever. We could say bind notifier interface to SMS notifier. Anytime a class needs a notifier interface, I want to use this implementation. Does that make sense? So that in this example, you can see this something class needs some interface, and I'm telling it to use some implementation, so that when I make something, it's going to use the implementation I tell it to use when I need that interface. Any questions on that? Staying with me? Okay, the thing Symfony people always ask me about in this scenario, because this is something they do a lot in Symfony. What if you need a different implementation somewhere else? So what if I need the SMS notifier in my vacation booker, but I want the email notifier in some other service? So you can do contextual container stuff, where I say, when vacation booker needs a notifier interface, give it the SMS notifier. So very simple, very fluent interface for configuring different implementations for different services. All right. Now, this was all Illuminate container. This is not necessarily Laravel stuff. This is just Laravel's container, which you can use in any project. So now I'm going to move to Laravel specific, how Laravel works. We need a place to put all this container stuff. The Laravel framework puts a lot of its own stuff in the container. The router, the event dispatcher, the exception handler, the email stuff, all that's in the container. Then your application puts all its stuff in the container. So your vacation business has the vacation booker and your notifiers and all that. And you need a place to register all this stuff and to kind of bootstrap that application. And so Laravel has this concept of service providers, which if you use Silex, is basically an identical concept as Silex service providers. So what a service provider does is it can kind of group these IOC bindings, these container bindings. So let's say I'm using the React database. I might have a React service provider which binds that React connection into the IOC container. And it might say it binds a few other React related things into the container. And it does that inside a register method, which will be called by the framework when this service provider is registered with the framework. The boot method is called after all other service providers have been registered. So the whole framework is bootstrapped. And this lets you override any other container bindings that might have been bound by the framework or any other providers. So it lets you kind of modify the IOC container at that point. Okay? So what that looks like in Laravel terms is, say we have a Laravel application, it has a register method which you can give it a service provider instance or just a string class name of a service provider, and that's going to call that register method. So now our React connection is going to be bound into the container. And then we can ask for it through the container make method. Okay, so that's service providers. And they're basically just a convenient way to add functionality, to add slices of functionality to your app. So you might have a React service provider. Maybe Laravel has a mailer service provider. It has a routing service provider. It has a queue service provider. So kind of every slice of functionality that Laravel has, there's usually a corresponding service provider that gives you that functionality into the container so that you can ask for it. Okay, so now I'm going to talk a little bit how all this IOC service provider mess comes together to really be the core of how Laravel works. And first, let me show you the Laravel directory structure. This is what the root directory would look like in a fresh Laravel application. And your app directory would be your code, your controllers, your services, your model, your domain model, all that is in app. Bootstrap basically creates the application and registers the composer autoloader stuff. So it's really just two files. It's two very simple files. The config directory has your authentication configuration, your mail configuration, maybe some debug configuration, stuff like that. Database has all your database migrations and your database seeds. Laravel database migrations look very similar to Rails database migrations. They have a very fluent syntax and works with MySQL, Postgres, SQL Server, SQLite. Public is going to be like your public images, your index.php, that kind of thing, your web accessible directory. Resources are several things. It's your CoffeeScript, your less, your Sass, your templates, your language files, like if your site is multilingual, your language translations and stuff would be in there. Storage is where Laravel writes, kind of like a var directory. It's kind of like it writes temporary files and caches and logs and stuff like that. And you can also write stuff here if you want. And then your test directory contains your unit tests or acceptance tests or whatever. Okay, so let me dig down one level into that app directory. And inside that app directory, you have an HTTP folder, which contains your controllers, your middlewares, and your requests. And then you have a console folder, and then you have providers. And the best way to think about this is HTTP and console are just two interfaces into your app. So I can access my app through HTTP, through the web, or I can access my app through the console, through the command line. They're just two light translation layers into your real application, if that makes sense. And then your providers directory has your service providers that we talked about earlier. So that's where things will be registered into the container. And then how you structure the rest of your application or how you structure your domain, TM, is up to you. And these are just light translation layers into that domain, if that makes sense. So you can add an infrastructure folder, a services folder, or however you like to structure your app. This is just a PSR4 namespace folder, so you can do whatever you want in there. Okay, now in the config directory, there's a very important configuration option called providers. And this just lists all the providers that we want to be registered with the framework when it boots. So as you can see here, there's an auth service provider, cache service provider, and there's a semi-long list of providers that are under there. But those provide those services into the container. And you can add or remove these as you want, and that's going to add or remove features from the framework. So if you install a package that provides a service provider, you install a React package, database package, you might add that React service provider, right here under your service providers. And that's going to make that stuff available to you. So providers add the features in a very literal sense. They add all the features to Laravel. Okay, so let's pretend we got an HTTP request. And we're going to walk through it from beginning to end. So where it starts is in public index.php. So a request comes in and your either Apache or Nginx configuration is directing all requests into index.php. So this is basically like a front controller pattern, which is common in most frameworks nowadays. Okay, and this is literally the real code. I mean, this is all the code that's in that file. I just removed the comments. And what happens is we're going to register the autoloader, and then we're going to get our app instance, which is a container instance. The Laravel app is just kind of a powerful container. And then we're going to make what's called an HTTP kernel, and we're going to pass it the request, which the Illuminate HTTP request extends the Symfony HTTP Foundation request. So if you're used to Symfony, all the same methods are, of course, available. And then that's going to give us a response. We're going to send it, and then we're going to terminate the application, which kind of gives you an opportunity to do anything like after the response has been sent to the user. So log something or whatever. Okay, so this kernel is very important, so I'm going to dig into that next. And what it does is first it bootstraps the application. These are like very foundational things, and it's literally just going to loop through this class of bootstrappers, or this array of bootstrappers, and it's going to make them and then call the bootstrap method, passing itself in. And these are very simple named classes, and they're very like kind of action word classes. So the first one is detect environment bootstrapper, and that's going to detect, it's going to read the .env file from your folder. It's going to set the application environment to like local or production or staging, that kind of thing. It's going to load the configuration, so your configuration files, so that it has all that. It's going to set up the exception handlers. And then, of course, two very important ones, or maybe the most important ones in terms of how Laravel works, are it's going to have a register providers bootstrapper and then a boot providers. And those correspond to those two methods on our service providers. So register providers is going to loop through. It's going to loop through this array of service providers and call register on each one. Okay, so that's what register providers does. And then boot providers is going to call boot on each one after they've all been registered. So at that point, your app is ready. Everything is in the container. Everything has been configured. The exception handlers are set up. We're ready to handle a request. Okay, so like I said, that load providers bootstrapper is literally just going to iterate through those providers and call register on each one. That's all it does. And at that point, we're ready to handle the request. Everything is in the container. The router is ready. Event dispatcher is ready. Everything. And it has this kind of real fluent syntax right here where it makes a new, what's called a stack. And it says, I want to send this request through this middleware, and then I want to dispatch to the router. So this is just copied and paste from the HTTP kernel in the Laravel core. Any questions so far before I transition to middleware? Yep.
Do you still have the defer property on service provider?
Yeah, the question was, do I still have a deferred property on a service provider? And the service provider concept, to give you some background, like I said, was inspired by Silex. However, one issue with that implementation in large applications is, say you have 30 service providers or 40 service providers. That can be time consuming to load on every request, and you don't need every service provider on every request. For example, like that React service provider, I don't need my React database connection on every request. So you can actually mark a service provider as deferred. And what that means is Laravel will not actually register that service provider until you need something that it provides. And it keeps a manifest, a JSON manifest of every service that every service provider provides, and so that when you ask for it, it knows what service provider to load. So a lot of core service providers are deferred. So I think the queue service provider would be a good one, or the mail one. Those are deferred, so those aren't actually loaded until you need the queue or you need an emailer. So it's a performance tweak. All right. HTTP middleware is basically this picture. This is a good way to picture HTTP middleware. And if you can see the layers kind of around this like core rock, picture this rock as being your application. And each of these lines is kind of a middleware. And so a request is coming in, and it's coming through these layers. And right here might be an authentication middleware. And right here, the request is going to get caught, and the authentication middleware is going to say, are we authenticated? If it's not, it's going to send out a response. It's not going to get any further into the app. If it is authenticated, we're going to jump to the next middleware, which might be CSRF token validation or verification. If that's invalid, we're not going any farther. So it's these little filters, so to speak, on the way into your application. Okay, like little HTTP layers. They can intercept and interrupt the HTTP request response lifecycle. And in Laravel, it ships with 5 or 6 middlewares. One of them is authentication, CSRF token verification. Are we in maintenance mode? So that it shows like a "we'll be right back" screen to your users. Those are all middleware. And what they look like in code is pretty simple. They just have really one method that's required called handle. And it receives a request, and then it receives a callback. And this is the authentication middleware. So I'm going to type hint the authenticator thing class, and it's going to be injected automatically because all middlewares are resolved out of the Ioc container that we learned about at the beginning. So I've got the auth implementation. I'm going to say, are they a guest? If they are, I'm going to return a redirect response right here. They're not going any further. If they are logged in, then I'm just going to pass the request to the next callback on the chain, just further down the line. And this middleware doesn't need to be concerned about what's next, what's further into the application. It just passes it along. Does that make sense? It's a little tricky at first, but it's a pretty powerful and simple concept. And it can be powerful because In PHP, we have like PSR7 coming up as a Fig standard, which will give us a standard HTTP request interface. And the reason this isn't type hinted is because I knew that was coming and didn't want to lock it down yet to any specific implementation. But say we have like a CORS middleware that sets certain response headers for CORS and AJAX access and all that. That could be shared across a lot of your applications or across different frameworks or even systems when we have a common request that we're all using, you know, across Symfony or Zend or Laravel or whatever. All right, so that's basically how an HTTP request works in Laravel. Now the other way, remember we have the HTTP folder and the console folder. So the console command looks like this. It looks very similar. We register the autoloader, we get a new application instance, and then we have a console kernel instead of an HTTP kernel. And this has a handle method as well, just like the HTTP kernel did, except it takes Symfony input and Symfony output implementations from their console component. Because HTTP requests obviously don't make a lot of sense here. And instead of returning an HTTP response, it returns a status code, which we then push back out. Now the console kernel is very similar to the HTTP kernel. It runs the same bootstrappers, detect environment, handle exceptions, load providers, boot providers. It's going to spin through all your providers, just like the HTTP kernel, except instead of handing the request to the router, it just hands it to the Symfony console component. So they're very similar. They're very similar in their architecture and the way they're set up. So you've got two kernels, both with handle methods. The HTTP kernel just takes a request. The console kernel just takes input and output. And they both return, either an HTTP response or a console status code. Okay, so picture those as just the two ways to enter your application. They load the providers, they execute the command either to the router or the console command, return the response, and it's a very simple way to think of the two ways to enter your application. And a very simple way to picture how Laravel works as a whole is through these two kernels and your service providers. Okay, and that's pretty much a summary of how Laravel 5 is architected. It's actually a pretty simple system. It's just service providers and registering with a container and handling the requests. It's not actually a very complicated framework. Okay, so what I can do is I can pull up like a basic Laravel app, and if you have any questions, we can actually just look at the code, in person if you want, and answer any questions you may have. Anything? Crickets. Eric, ask your question. Yeah.
This may not be something you can just look at, but with middleware, can you use that to, for example, protect, make sure somebody owns a resource before they can even get to your drawer method? Like they have the ability to do that as a user.
Yeah, you could, but I would probably do it like a little differently. In this HTTP folder, there's this request thing, and right in this, you can see this login request has this authorize method. So say you had an edit user thing like you were talking about. You might have an edit user request. And in that authorize method, you would check if the authenticated user can perform this action, and you would just return true or false. If you return false, it's going to return a 403 forbidden for you. And it's going to do that if you just type in it. It will run authorized before it gets injected in because it's an HTTP request. And if it returns false, your authorized method, you won't even make it this far. Like you won't even make it into the method. You'll just get the 403. So that's a really simple way to do authentication without kind of like cluttering up the controllers. Yep.
You mentioned size a couple of times in the explanation or Laravel size. What would you say is the big difference and why is Laravel better or not?
The question was, what's the big difference between Laravel and Silex? And the big difference is we ship a lot of service providers out of the box. So Silex comes without a lot of the other features like authentication or queue or any of that. Laravel is like Silex on a lot of steroids, like a lot of service providers baked in, or like batteries included. It's also a little different in that it doesn't use the StackPHP anymore. It uses our own kind of middleware stack implementation. But it just has more features out of the box, and it's a very similar framework. The main difference is just what it includes and how it's set up out of the box. Yep.
I know you throw events when an element saves to the database.
Yeah. Mm-hmm.
But is there any way to really get to that lower level, eliminate, so that all queries, at least you get that standard object back instead of just the SQL query?
Like you get the query builder object?
Well, I'm trying to look into the events so I can just cache versions of every single time the database state changes between the table. And had to do some really hard extending of deep in the eliminate database.
Yeah.
Just wonder if there's an easier way.
I don't know. I mean, we can kind of hack on it afterwards if you want, and you can show me what you have, and I can take a look at it.
Hello? Okay. So are Laravel 5 middlewares different from Laravel 4 filters functionally in terms of like scope or how they can be used, or is it mostly just reorganization, rebranding?
Okay, the question, okay, I guess you heard the question since he has a mic. Middlewares are not different in terms of their purpose. They're different in terms of, for example, in Laravel 4 we had before filters and after filters, and we had global before filters and global after filters, and those had different signatures that you had to remember. So an after filter might receive the request and the response, or like the router, the request and the response. Before filter doesn't receive any response, it's just a request and maybe no route. The thing with middlewares is it's always the same. So it's much simpler for you to remember. You just have to remember the one handle method takes a request and a next. No matter if you're going to do stuff after or before the request, it's always the same. So yeah, I think you're right that they're the same purpose. It's just a simpler implementation. And filters are still available in Laravel 5. I mean, it's not removed or anything. It's just kind of middleware, so the encouraged default.
I brought up the mic so nobody else.
All right. Well, I'll be around. So thanks a lot for your attention.